This next example is a little bit different, and let's take a look at it. Still looking at nitrogen gas. Still looking at the probability. Here we've got a nitrogen gas. Again, I looked up theta vibrational. Actually, in this problem, I think the statement of the problem was that consider a nitrogen gas, and then in parentheses they gave you theta vibrational. And then they tell you that a spectroscopic measurement finds that the number in the ground state in the number of particles in the ground state to the total number of particles is 75%, or so 3/4 of the particles are in the ground state. And then what's asked was what's the temperature of the gas when this measurement was made, this spectroscopic measurement was made. And they don't really say that this is vibrational, but the fact that they give you the theta vibrational up here says, well, they're looking at just the vibrational mode. So, and as we saw earlier, the probability that you're in the mode M is given by this expression. And now it's a little bit different in that I know I evaluate this for the ground state, P0, and that's 7.75, 3/4. So I know P0. When I put in 0 here, this term goes out. It's just e to the 0, which is 1, and then I just have this factor. But I know now, or I'm given that the probability of being in that state is 0.75, and so I have to have this expression. And then it's a matter of solving that equation. And what I did was I took the 1 over to this side, so that gave 0.75 minus 1, so I get minus 0.25. The minus signs will cancel, and then I switched sides here. Okay. And then what did I do? Then I took the natural log of both sides, because the natural log of the natural exponent just gives me the argument, and the natural log of 0.25 I can calculate. When I calculate the natural log of 0.25, any fraction is going to have a negative log, and so this gives me a negative 1.38 when I calculated that in my calculator. And the minus signs go out, and then I can solve what's left for the temperature. It's 3374 Kelvin divided by 1.386. And then if you look at it, that's at a little over 2400 Kelvin in temperature. So you can see that to get even 3/4, that's a large percentage. I have to be at a significantly high temperature in terms of any real, at least in terms of ordinary temperature, this is certainly significantly high.